This question is asking you to add the numbers 50 and negative 65 together and express your answer in 8-bit 2's complement. I've written down a couple of steps here for the solution just to help you with that. So convert both numbers into their binary equivalent. That's the first thing you want to do. Then add the numbers together and then check your answer. So we've got two numbers here. We've got 50, which is a positive number, and we've got negative 65, which is a negative number. And as you know, all negative numbers are expressed in 2's complement in a computer system. So negative 65 is 2's complement, 50 is not 2's complement. So let's start with the first number, 50. Let's put the place values in. So 1, 2, 4, 8, 16, 32, 64 and 128. We know that 50 is made up of 32. We've got 18 left, so we need a 16 and a 2. So we don't need those, so we'll put zeros in there. So 50 is 00110010. Negative 65 needs to be converted using 2's complement. So let's put down 2's complement and remember how to do this. So 2's comp, there are 3 steps. So step 1, what is it? Find the positive. Step 2, can you remember what that is? That's flip. And step 3, can you remember what that is? Add 1. Okay, let's do that. So put down our grid as normal. So we've got 1, 2, 4, 8, 16, 32, 64 and 128. So the first thing we're doing is finding the positive 65. So we don't need that. We need a 64 and we also need a 1. 64 and 1 is 65. Now we need to flip. So 1, 0, 1, 1, 1, 1, 1, 0. And now we need to add 1. So let's put in a 1. And I like to put a line above and below it just so that I'm clear on what it is that I'm adding, because this can sometimes be a bit confusing. Right, so 0 plus 1 is 1, 1 plus 0 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 is 1, 0 plus 0 is 0, 1 plus 0 is 1. So there is the answer. This is minus 65. Now we can test this to make sure it is minus 65 before we go any further. So let's write down here minus 65, and we know how to test 2's complement, don't we? This most significant bit, which in this case is the 2 to the power 7, is minus 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So let's get our calculator and check that. So we start with 128, change the sign to negative, plus 32, plus 16, plus 8, plus 4, plus 2, plus 1, and that's minus 65. So that equals minus 65. With confidence, we can add these two binary conversions together. So let's do that now. So we'll start off with 50. We'll just write 50 over there, and then we'll write plus minus 65, and then we'll write down what they are. So we know that 50 is 0, 0, 1, 1, 0, 0, 1, 0. And we know that minus 65 is 1, 0, 1, 1, 1, 1, 1, 1. Right, let's add these together. So 0 plus 1 is 1. 1 plus 1 is 2. Let's write that down. 1 plus 1 is 2. Yeah? So we write down 2 and we carry the 1. 1 plus 0 plus 1 is 2. Put down the 0, carry the 1. 1 plus 0 plus 1 is 2. Put down the 0, carry the 1. So 1 plus 1 plus 1, let's do that one. 1 plus 1 plus 1 is 3. A 1 and a 2 together gives you 3. So we put down a 1 and carry the 1. 1 plus 1 plus 1 is 3. Put down the 1, carry the 1. 1 plus 0 is 1. 0 plus 1 is 1. So this is our answer. The answer is in 2's complement, but we need to check it to make sure it is correct. So we know just in our heads that 50 plus minus 65 is minus 15, don't we? So let's go ahead and check this to see that we're correct. So it's in 8 bits, so this most significant bit is negative 128 plus 64 plus 32 plus 16 plus 1. So let's get the calculator and check this answer. So 128 negative plus 64 plus 32 plus 16 plus 1 equals negative 15. So you have checked your answer. And the negative 15 is what you were expecting. So our answer is 1, 1, 1, 1, 1, 0, 0, 1.